the synthesis of oil of wintergreen. In this procedure, Mary Rose and I attempted to make oil of wintergreen, otherwise known as methyl salicylate, from 2 normal tablets of aspirin. We did this through a Fischer esterification reaction, a type of nucleophilic acyl substitution. We then attempted to purify the oil using an organic chemistry procedure known as extraction, using a separatory funnel.
Okay, so here are the materials we used in the lab. And before we get into the video, here is an overview of our procedure. This lab took us multiple days to complete, so this procedure was not done in one fell swoop. Now, on to the videos.
Here are our 2 tablets of aspirin. And here are our 2 tablets of aspirin being crushed to dust. Rest in pieces, aspirin tablets, 2019 to 2019.
And now, we can see the wild Elizabeth failing to pour the aspirin dust into the vial. Look at her go! And she's almost got it. Our next task was to measure 5 milliliters of methanol.
And here we can see Mr. trying to measure the methanol. Oh no, she missed the granulated cylinder. Oh no, oh god.
Shh. Okay, now on to the next part, where we mix the aspirin with the methanol.
Even though there is an excess of methanol to the aspirin, it will not fully dissolve. And now Dr. Hansen has come in to help us by adding in the concentrated sulfuric acid. This stuff is not a joke, it is 18 molar, so stay safe, kids.
The purpose of the water bath is to help a portion of the reaction take place and to take advantage of Le Chatelier's principle, since the esterification reaction is an equilibrium reaction. The heat helps the water separate from the molecules. More on that later. And also helps it evaporate, which pushes the reaction forward. And next, we took it out of its nice warm bath.
Here we are making a sodium bicarbonate solution which we can use to neutralize the sulfuric acid. This reaction produces violent fizzing. The way we know it's fully neutralized if the solution stops fizzing. And now, we present the random clips we collected while waiting for the fizzing to stop. Hello.
Don't wreck my tabletop, Dot.
Hi, baby. Hi, baby. You're getting nice and cool, baby. I hope y'all are ready to see some fizz.
Fizz. More fizz. And more fizz.
We want to show our son contained in his prison as he bubbles away.
And here is the completed, not fizzy product.
And now, 2 high school students attempt a complicated organic chemistry process.
For the extraction, we place 5 milliliters of our super impure solution into the separatory funnel, along with 5 milliliters of ethyl acetate.
And here we are waiting for it to separate. Wait!
Unfortunately, while we did separate the layers correctly, we didn't get a video of us doing it since we were stressed about getting it right. Sorry, y'all. Anyway, here is us trying to evaporate the ethyl acetate. We did this for a period of 10 minutes to seemingly no effect. We were running out of time, so we took out the beaker and placed a watch glass on it, thinking it'd be fine.
Who can say where the road goes, where the day flows?
We had no idea what happened, but the ethyl acetate and oil of wintergreen solution turned black. There was nothing else we could do. On the flip side, though, our impure solution actually did smell of wintergreen. So, while the extraction failed, we achieved our objective.
Okay, so that's all well and good, but what's actually happening here? Well, you guys are all in luck, because it is time for Liz's Chem Closet. I'm about to learn y'all a thing while in my dusty, dusty closet. Let's go ahead. Okay, so Pfister esterification, a complicated name for a not so complicated process. As mentioned before, it is a nucleophilic acyl substitution. This involves a nucleophile, otherwise known as an electron donator, and an acyl, a functional group with the formula RCO, shown below. And in this case, it is also an electrophile, or an electron receiver. In this type of substitution, the nucleophile reacts with the compound with the acyl and replaces it. Now that we got all that general esterification down, let's get specific to our reaction. So I have our lovely reaction pulled up here, so you all can see what it looks like generally. Note that it is an equilibrium reaction. That is very important. So now that you see this, I'm going to actually pull y'all up here so that I can manipulate it a little bit more. So in terms of this reaction, you're really not going to be focusing on the full molecule of aspirin or oil of wintergreen. You're actually only really going to be focusing on these two arms. This arm is the completed, that's after all the change, after the substitution, and then this arm, which is known as a carbonyl carbon. And from now on, I'm going to be referring to it as a carbonyl group. So in this reaction for the substitution, the nucleophile is the methanol, specifically that OH, and your acyl, sorry for my pronunciation, is going to be this carbonyl group. I'm going to actually simplify this up a little bit, just so it makes everything a little easier. Boom. Just to make everything look a little easier to, chew, digest. So, the thing is with this reaction, specifically, aspirin is a carboxylic acid, which, unlike something like an ester, is not that great of an electrophile, especially in neutral solutions. So, that is why we have our lovely catalyst, sulfuric acid. But what does the sulfuric acid actually even do? And that is how we're going to go into the actual reaction. So this actual reaction is a nice, easy, simple-ish 5-step process. So bear with me here, I'm going to walk you guys through the 5 steps. First things first, our lovely sulfuric acid donates this lovely H. So, this becomes negative, and this is a H plus, and this H plus walks itself on over here. And this addition of the positive charge makes the carbon and the oxygen single bonded, but it also attracts our nucleophile, the OH on that methanol. Since they're attracted and since this is activated, the second step is that this lovely friend here bonds to, or attacks, the aspirin molecule. This makes this nice intermediary phase because everything's a little shaken up, everything's not really what it's supposed to be. Since we're in this intermediary phase, and you might notice that our lovely oxygen right here is nice and satisfied, but it's oversatisfied now. So what does it do? It gives a hydrogen all the way up to this oxygen up here. That was step 3. And now some of you might notice that this looks awfully familiar. That would be because it is a water molecule. This water molecule actually just leaves. So, the water leaves. Since the carbon lost a bond, it's not satisfied anymore, it rebonds to this oxygen. And you might notice if you look, right now we are awfully close to being oil of wintergreen. We got one little problem, that nice hydrogen up here. Now that we're double bonded back again, what does it do? Well, it actually goes back and just reunites with the sulfuric acid. And this restoration of the sulfuric acid is why it's considered a catalyst and not a reactant. With all this being done and all of this said, you might notice that these are exactly the same, meaning our reaction is complete. So if our reaction is complete, some of you may be asking, why on earth did we heat the solution and use so much methanol? Well, as I mentioned before, this reaction is not very favorable. Like Pfister esterification is not very favorable at all. Our procedure was set up to try and, use our little friend Le Chatelier. So the excess of methanol was in hopes that because there was so much reactant, it would push the reaction forwards more. And then also the heating had dual purpose. Part of it was to help that water get kicked off during step 4. And also relating to the water, the heating helps evaporate some of that water, meaning product is gone, pushing that reaction forwards. Fun times. And with that all wrapped up, this looks like the end of the road, folks.
This was a really fun lab to do and video to make.
And overall, this class was such a fun and informative time.
So thank you all for making it as amazing of an experience as it was.
And with that, thanks for watching, kids. Subscribe to our YouTube channel and don't forget to dissolve that like button. Farewell!